The chapter name is Goods and Financial Markets. That's the ISLM model. In this chapter, chapter 3, we looked at the goods market. In chapter 4, we looked at financial markets. We now look at goods and financial markets together. By the end of this chapter, you will have the framework to think about how output and the interest rate are determined in the short run. In developing this framework, we follow a path first traced by two economists, the John Hicks and Alvin Hansen. In the late 1930s and early 1940s, when the economist John Maynard Keynes published his general theory in 1936, there was much agreement that his book was both fundamental and nearly impenetrable. Try to read it and you will agree. There were and still are many debates about what Keynes really meant. In 1937, John Hicks summarized what he saw as one of the Keynes' main contributions, the joint description of goods and financial markets. His analysis was later extended by Alvin Hansen. Hicks and Hansen called their formulation the ISLM model. Macroeconomics has substantial progress since the early 1940s. This is why the ISLM model is treated in this and the next chapter rather than in chapter 26 of this book. If you had taken this course 40 years ago, you would be nearly done. But to most economists, the ISLM model still represents the essential building block, one that, despite its simplicity, captures much of what happens in the economy in the short run. This is why the ISLM model is still taught and used today. This chapter develops basic version of ISLM model. It has five sections. Section 5.51 looks at equilibrium in the goods market and derives the IS relation. Section 5.2 looks at equilibrium in financial markets and derive the ISLM relation. Section 5.3 and 5.4 put the IS and LM relation together and use the resulting ISLM model to study the effects of fiscal and monetary policy, first separately and then together. Section 5.5 introduces dynamic and explores how the ISLM model captures what happens in the economy in the short run, the goods market and the IS relation. Let's first summarize what we learned in chapter 3. We characterized equilibrium in the goods market as the condition that production Y be equal to the demand for goods Z. We call this condition the IS relation. We defined demand as the sum of consumption, investment, and government spending. We assumed that consumption was a function of disposable income minus taxes, and took investment spending, government spending, and taxes as given. That's Z equals to C in the bracket Y minus T plus I bar plus G. Okay, this is the equation. Okay, this is the equation. Z equals to C into the bracket Y minus T plus I bar plus G. In chapter 3, we assume to simplify the algebra that the relation between consumption C and disposable income Y minus T was linear. Here, we shall not make this assumption but use the more general form C equals to C into Y minus T instead. The equilibrium condition was thus given by Y equals to C into the bracket Y minus T plus I plus G. Using this equilibrium condition, we then looked at the factors that moved equilibrium output. We looked in particular at the effects of changes in government spending and of shifts in consumption demand. The main simplification of this first model was the interest rate did not affect the demand for goods. Our first task in this chapter is to abandon this simplification and introduce the interest rate in our model of equilibrium in the goods market. For the time being, we focus only on the effect of interest rate on investment and leave a discussion of its effects on the other components of demand until later. Investment, sales, and the interest rates. In chapter 3, investment was assumed to be constant. This was more for simplicity. Investments is in fact far from constant and depends primarily on two factors, Number one, the level of sales. Consider a firm facing an increase in sales and needing to increase production. To do so, it may need to buy additional machines or build an additional plant. In other words, it needs to invest. A firm facing low sales will feel no such need and will spend little, if anything, on investment. The interest rate. Considering a firm deciding whether or not to buy a new machine, suppose that to buy the new machine, the firm must borrow a higher interest rate. The less attractive it is to borrow and the buy the machine. For the moment, and to keep things simple, we make two simplifications. First, we assume that all firms can borrow at the same interest rates, namely the interest rate on bonds as defined in the chapter 4. In fact, many firms borrow from banks, possibly at a different rate. We return to this chapter in we return to this in chapter 9. We also leave aside the discussion between the nominal interest rate, the interest rate in terms of dollars, and the real interest rate, the interest rate in terms of goods. The distinction is important, however, and we return to it in chapter 14. At a high enough interest rate, the additional profits from using the new machine will not cover interest payments, and the new machines will not be worth buying. To capture these effects, we write the investment relation as follows, that is I equals to I y comma I plus or minus. Those effects will be, one is positive effect, interest rate is negative effect. You should be keeping those in mind. Equation 5.1 states that investment I depends on the productivity and interest rate I. We continue to assume that inventory investment is equal to 0, so sales and production are always equal. As a result, Y denotes sales and it also denotes production. The positive sign under Y indicates that an increase in production, equivalently an increase in sales, lead to an increase in investment. The negative sign under the interest rate I indicates that an increase in the interest rate leads to a decrease in investment. Determining output. Taking into account the investment relations 5.1, the condition for equilibrium in the goods market become Y equals to C into bracket Y minus T plus I, that is depend upon output and interest rate plus government expenditure. Production. The left side of the equation must be equal to the demand for goods, the right side. Question 5.2, that is this one, is our expanded IS relation. We can now look at what happens to output when the interest rate changes. Start with figure 5.1. Measure the demand for goods on the vertical axis. This one is the figure. Measure output on the horizontal axis for a given value of the interest rate I. Demand is an increasing function of output for two reasons. An increase in output leads to an increase in income and thus to an increase in disposable income. The increase in disposable income leads to an increase in consumption. We studied this relation in chapter 3. An increase in output also leads to an increase in investment. This is the relation between investment and production that we have introduced in this chapter. In short, an increase in output leads, through its effects on both consumption and investment, to an increase in the demand of goods. This relation between demand and output for given interest rates is represented by upward sloping curve ZZ. That's demand. Note 2 characteristics of ZZ in figure 5.1. Since we have not assumed that the consumption and investment relations in equation 5.2 are linear, ZZ is in general a curve rather than a line. Thus, we have drawn it as a curve in figure 5.1. All the arguments that follow would apply if we assume that the consumption and investment relations were linear and that demand were straight line. Okay, Afterwards we can look at these equation diagrams. This one is for equilibrium in goods market. Here is the equilibrium point, and they have provided that the demand for goods is an increasing function of output. Equilibrium requires that the demand for goods be equal to output. Derivation of the IS curve is the second figure. Here they have provided how they both can be interpreted with the output and interest rate and output and demand. That's derivation of IS curve. An increase in the interest rate decreases the demand for good at any level of output, leading to a decrease in the equilibrium level of output. Equilibrium in the goods market implies that an increase in the interest rate leads to a decrease in output. The IS curve is therefore downward sloping. Okay, here. Okay, we will come to the next point. We have drawn ZZ so that it is flatter than 45-degree line. Put another way, we have assumed that an increase in output leads to less than 1-for-1 increase in demand. In chapter 3, where investment was constant, this restriction naturally followed from the assumption that consumption spends only part of their additional income on consumption. But now that we allow investment to respond to production, this restriction may no longer hold. When output increases, the sum of the increase in consumption and the increase in investment could exceed the initial increase in output. Although this is theoretically possible, the empirical evidence suggests that it is not the case in reality. That's why we will assume that responses of demand to output is less than 1-for-1 and draws is flatter than 45-degree line. Equilibrium in goods market is reached at the point where the demand for goods equals output. That's a point A in the figure they are provided above. The intersection of ZZ and that's intersection of line demand line and the 45-degree line, thus the equilibrium level of output is given by Y. So far when we have done is extended is straightforward fashion the analysis of chapter 3, but we are now ready to derive the IS curve.